Floods, droughts, heavy rains, wildfires, and cyclones are all common examples of climate disasters. However, these calamities have recently become more intense, such as during the rainy season when it rains so heavily that it causes flash floods. Again, summers are so hot that they break all prior records, resulting in heat waves. Meanwhile, in 172 years, 2022 has been the second hottest year for the whole of Europe. In these disasters, huge dollar losses are recorded every year. For example, in just 1 year, natural disasters and climate change causes 165 billion in damage in the United States. The world is also facing various natural disasters, including frequent fire cyclones, which affect the global economy, including freshwater supply, food production, and public health. Now the question is why the natural calamities are getting more intense and why there is sometimes heavy rain and sometimes drought in the same place. To understand the cause of heat waves, it's important to understand weather patterns such as La Niña and El Nino, as well as the jet stream. Today's video, we will discuss La Niña, El Nino, and the jet stream. In the 17th century, fishermen along Peru's coast discovered that the Pacific Ocean's water were relatively warm around Christmas time every few years. This occurrence was given the title of El Nino, which means boy in Spanish. Since the warm water came at Christmas time, El Nino meant they originally referred to Jesus' son. After the warm water, they again noticed the presence of relatively cooler water. The reason for such periodic difference in water temperature in the Pacific Ocean was unknown for a long time. Finally, in the 1960s, people understood why the water temperature difference in the Pacific Ocean occurs. It is also understood that the rise in the temperature of the waters of the Pacific Ocean affects the entire world's climate, which is now called El Nino Southern Oscillation, abbreviated as NSO. Since the matter occurs periodically, it has three phases. Firstly, La Niña phase, secondly, neutral phase, and thirdly, El Nino phase. But to understand this thing, you need to understand a very basic thing, and that is high pressure and low pressure. Only by understanding these two factors will you have a clear understanding of various weather-related topics, including El Nino and La Niña. Consider two containers full of water at a certain distance. Now if one of them is continuously heated and the other is continuously cold, the water in the heated container will evaporate and rise, i.e. the air there will become lighter and rise. Now that the air is going up, the pressure will decrease in this place, which means that a low pressure zone will be formed here. On the other hand, since no steam will be created in the container where the water is being cooled, the air there will cool down and become denser, so the pressure will increase here. That is, a high pressure zone will be created in this part. Now we know that any object always wants to move from a high pressure region to a low pressure region. That means here the flow of air from the high pressure part to the low pressure part will be seen. Now you may think that is very normal, but this matter does not end here. See here, the water vapor is rising from the low pressure area. It will go up, but it will cool, due to which the pressure will continue to rise. It means low pressure at the bottom, but high pressure will be created by going up. But this high pressure air cannot descend into the low pressure area. Because the air is already rising from here, the high pressure air created above will move along the sides and come down. Now, if we consider moving along the side in this direction, notice that there is a cycle of air flow forming here. This cycle is the driving force behind all weather variations, including the Earth's wind and precipitation. We experience this downdraft mainly from the Earth's surface. Here, as water vapor rises from this region, clouds will form in this region. As a result, there will be rain around the hot pot, while the cold water area will not get any rain, so it looks like a desert. Now talking about high pressure and low pressure resulting in variation in airflow with precipitation, as we have understood it so far. But initially, high pressure and low pressure require hot and cold water, or a hot and cold environment. But the question is, how on earth the variations of hot and cold are created till the sun will come forward? Sunlight does not fall equally on all parts of the earth. Sunlight falls vertically in the equatorial and surrounding regions, while it falls obliquely in the polar regions. Now as the sunlight does not hit all parts of the earth with equal intensity, the center of the earth is hotter and the polar regions are less heated. Now the temperature difference creates low pressure in the center of the earth and high pressure in the polar regions. As a result, air flows from the polar region to the equatorial region. However, the wind does not come directly from the poles to the equator, but a pattern is formed. And the airflow you see along this pattern is the directions of the Earth's airflow. Now let's talk about how El Nino and La Nina are formed. Along with the airflow from the Earth's pole to the equator, there is another type of airflow. That is the airflow from east to west or west to east, which is created as a result of the rotation of the Earth's axis. As a result of the Earth's rotation, the wind coming from the poles to the equator bent westward by the Coriolis force. As a result, there is an east to west airflow in the equatorial region and its vicinity. And this airflow mainly causes El Nino and La Nina. El Nino and La Nina originate from the Pacific Ocean. The surface water in the equatorial Pacific Ocean is heated by sunlight. But the east to west winds created at the equator due to the Earth's rotation move the surface water over the oceans westward. As a result, the ocean waters in and around Australia are relatively warmer than those in Peru and Chile. The result is that the air over Australia becomes lighter and rises, i.e., low pressure forms. On the other hand, high pressure prevails in this part, which results in a cycle of airflow called worker circulation, like the hot and cold water mentioned earlier. Now, under normal conditions, the sky in this region has more water vapor, forming clouds and resulting in precipitation. On the other hand, due to the high pressure in this area, there is no water vapor in the sky, so there is no rain in the coastal areas of Peru and Chile. As a result, deserts exist in the part of Chile. Now, when this normal state of the Pacific Ocean is disturbed, El Nino and La Nina come to the fore. First, let's talk about La Nina. If for some reason warmer than normal water moves from east to west, then it is called La Nina. That is, what happens in normal conditions. If the level is higher, it will be called the La Nina effect. In such cases, warmer than normal water accumulates in parts of Australia, creating more water vapor which causes more than normal rainfall in the region, resulting in flash floods, as well as more cyclones than normal. On the other hand, in the coastal area of Peru and Chile, the cold water from the sea bottom rises, which means that there is more high pressure than usual. As a result, this area becomes drier than normal, resulting in drought. However, there is one distinct advantage to this event in coastal Peru: the upwelling of cold ocean water, which provides food for the fish. This means that fishermen can catch more fish than normal. The opposite of La Nina is called El Nino. If the flow of air from east to west is less than normal, it is called El Nino. In such a case, due to less westward wind flow, warm sea surface water tends to come eastwards instead of westwards. As a result, a lot of water vapor is created in roughly in middle of the Pacific Ocean. As a result, there is a lot of rain in Peru, Chile and the Pacific Ocean, which also causes sudden floods in Peru and Chile. On the other hand, there is no rain in Australia or its surrounding areas, resulting in droughts or fires. Now, El Nino and La Nina not only change the weather of these two regions, but also the strong El Nino and La Nina change the weather of the entire world. As a result of El Nino and La Nina, what is supposed to happen under normal conditions occurs very intensely, as a result of which El Nino and La Nina causes noticeable changes in the climate of the entire world. El Nino and La Nina occur periodically after roughly a few years. Although their intensity is not always the same, sometimes it seems to be less and sometimes more. For example, the last 30 years have seen two extremes of El Nino, the first from 1997 to 1998 and the second from 2015 to 2017. In general, ENSO is a fairly normal event throughout history, but appears to be increasing in intensity, behind which excess greenhouse gas emissions are responsible, but scientists are still not clear about the real reason. Lately, there is a phenomenon like heat waves during the hot season, which is unbearably hot weather. Again in winter, more cold flow is seen than normal time. Behind this is the effect of ENSO, which affects the jet stream and creates heat or cold waves. Now the question is how the jet stream creates heat or cold waves. At the meeting point of the winds coming from the Earth's pole to the equator, a strong current of the air is formed called the jet stream. This jet stream is of two types: a subtropical jet stream and the other is a polar jet stream. Important for us is the subtropical jet stream. The trajectory of this jet stream is not straight but like a sine wave. Now a large amount of air enters from below the part of the wave that goes up, On the other hand, the part of the wave that descends causes a lot of air to escape. Now, there is a low pressure at the point where the air enters the jet stream and high pressure at the point where the air is coming down. Now think of a place where hot air is trying to rise. But if there is a lower part of the jet stream over that place, the air that wants to rise will not be able to rise due to the air coming out of the jet stream. Rather, the air coming out of the jet stream will continue to compress the air in that place, i.e. increasing the pressure. Now we know that compressing a gas or air causes its temperature to rise. Now the hot air cannot rise from this place. The air coming from the jet stream is compressing the air here, and this compression causes the temperature to rise further. These two factors combine to form a high pressure zone where hot air is trapped and is called a heat wave. The heat wave causes the temperature to rise significantly, creating a hot environment. Where the opposite of a heat wave occurs, a cold wave is seen. As you may have observed in the video, the difference in pressure plays a crucial role in determining the direction and intensity of air movement, as well as weather patterns. A better understanding of a pressure difference leads to a better comprehension of various weather phenomena. Did you know that there is a metal that can remember its initial shape? It's called nitinol. If you find this surprising, you may want to watch this video to learn more about it. And if you like the video, you can subscribe to our channel.